The traditional voting system has been an integral part of democratic societies for centuries. However, it's not without its flaws, including issues related to security, transparency, and accessibility. In recent years, blockchain technology has emerged as a potential solution to these problems. This video explores in detail how blockchain can be applied in digital voting to enhance the security, transparency, and accessibility of the electoral process. Before we begin, if you are not yet subscribed, please subscribe to the channel and like this video so that it can be recommended to others. Understanding blockchain technology. Blockchain technology is a decentralized and distributed ledger system. It consists of a chain of blocks, each containing a list of transactions. These transactions are recorded in a transparent and immutable manner. What sets blockchain apart is its security and transparency, which are achieved through cryptographic methods, consensus algorithms, and decentralization. Applying blockchain to digital voting. Blockchain technology offers numerous advantages when applied to digital voting. Let's delve deeper into each of the key aspects of this application. 1. Enhancing security. Security is a primary concern in any voting system, and blockchain offers a robust set of security features that can significantly improve the integrity of the digital voting process. In the context of digital voting, immutability is a critical feature of blockchain. Once a vote is cast, it's recorded as a transaction in a block. Once added to the blockchain, this transaction becomes irreversible. Any attempt to tamper with or erase votes requires consensus from the network, making fraud exceptionally challenging. This immutability instills trust in the integrity of the electoral process. Blockchain technology leverages advanced cryptographic techniques to secure votes. When a voter casts a vote, it's encrypted, ensuring that only authorized individuals can access the data. The cryptographic keys, generated during the voting process, serve as the gatekeepers to protect the votes from unauthorized access or manipulation. This cryptographic layer adds an additional level of security to the entire process. Blockchain operates on a decentralized network of computers, known as nodes. This decentralization is a fundamental characteristic of blockchain and is a powerful tool for safeguarding digital voting. Unlike traditional centralized systems, where a single server or authority oversees the voting process, blockchain operates on a network of nodes. Each node independently verifies and records transactions. In the context of digital voting, this decentralization makes it extremely difficult for any single entity to manipulate or compromise the results, reducing the risk of fraud and ensuring that the process is trustworthy. Transparency is a cornerstone of the blockchain philosophy, and it holds great relevance in digital voting. Every participant in the blockchain network can independently verify the legitimacy of each vote. This transparency is a result of the blockchain's public ledger. In a public ledger, every transaction, including votes, is recorded and accessible to anyone. This open accessibility allows for the auditing of the voting process by various stakeholders, including election observers, voters, and third-party organizations, ensuring the process's fairness and legitimacy. One of the most significant advantages of blockchain in digital voting is transparency. Transparency in voting ensures that the process is fair, legitimate, and free from manipulation. Blockchain achieves transparency in the following ways. 2. Public ledger. The blockchain is a public ledger, meaning that it is accessible to anyone. Anyone can review the blockchain to audit the voting process and verify the results independently. This transparency ensures that the process remains open and subject to public scrutiny, reducing the likelihood of fraud or corruption. Votes are recorded and updated in real time on the blockchain. This allows for immediate access to election results. Real-time updates can provide both voters and election officials with the most up-to-date information on the progress of the election. This transparency is particularly important during fast-moving election events, ensuring that information is readily available to stakeholders and the public. Blockchain technology enables end-to-end verification of votes. Each vote can be tracked from the moment it is cast to when it is counted. This end-to-end verification ensures that votes are not lost or manipulated during the process. It also builds confidence among voters, knowing that their votes are accounted for throughout the entire process. Blockchain technology has the potential to make the voting process more accessible, allowing a wider range of people to participate in the democratic process. 3. Inclusivity. Blockchain enables secure remote voting, allowing individuals to cast their votes from anywhere with an internet connection. This is particularly beneficial for those who are unable to physically visit a polling station, such as individuals with disabilities or citizens living abroad. Remote voting can be conducted through user-friendly interfaces, making the process convenient and accessible. Eliminating intermediaries and paper-based systems reduces the barriers to entry for voters. The voting process becomes more straightforward and less time-consuming. Blockchain-based digital voting streamlines the process and makes it more accessible to a broader range of people, including those who may have found traditional voting systems cumbersome. Blockchain voting systems can be designed to be more inclusive of differently abled individuals. By incorporating accessibility features, such as voice commands or screen readers, digital voting becomes more accommodating for those with visual, auditory, or mobility impairments. This commitment to inclusivity ensures that all citizens have the opportunity to participate in the democratic process. Challenges and considerations. While blockchain offers substantial advantages in digital voting, several challenges and considerations must be addressed in detail to ensure the successful implementation of blockchain-based voting systems. 1. Identity verification. Ensuring the secure and private verification of voters' identities is critical. Traditional identification methods may not be directly applicable to blockchain voting. Blockchain-based identity solutions, such as self-sovereign identity, must be implemented to confirm the eligibility of voters without compromising their privacy. Self-sovereign identity allows individuals to have control over their personal data and selectively share information, which can be critical in maintaining privacy while verifying identity. 2. Scalability. As blockchain networks grow, scalability becomes a concern. The voting system must be able to handle a large number of transactions, especially during peak voting times, to prevent congestion and delays. Detailed discussions and planning regarding the technical infrastructure, network capacity, and scalability solutions are essential to ensure that blockchain-based voting systems can handle the demands of large-scale elections without compromising speed and reliability. 3. User-friendliness. Blockchain technology can be complex for the average voter. User-friendly interfaces and educational campaigns are essential to make the technology accessible to all, regardless of their technological literacy. Additionally, it's crucial to design voting platforms that are intuitive and easy to use, taking into consideration the diverse range of voters, including those who may not be tech-savvy. 4. Privacy. While transparency is crucial, maintaining voter privacy is equally important. Blockchain voting systems should incorporate strong privacy protection measures to ensure that votes remain confidential and are not linked to individual voters. Privacy-focused cryptographic techniques and privacy-enhancing technologies should be an integral part of the voting system. 5. Regulatory and legal issues. The legal framework for blockchain-based voting must be established and accepted by governments and election authorities to ensure the legitimacy of the process. Regulations should address issues such as dispute resolution and voter recourse in case of issues or discrepancies. These regulations should also define the roles and responsibilities of various stakeholders, including blockchain network validators, election authorities, and technology providers. They should also address the legal status of blockchain transactions in the context of voting and ensure that the voting process complies with existing electoral laws. While blockchain is known for its security, it's crucial to implement additional security measures to protect the voting system from various threats. This includes protection against distributed denial of service, DDoS, attacks, advanced encryption techniques, and continuous monitoring for suspicious activities. The voting system should also have a well-defined incident response plan in place to address any security breaches promptly. To ensure that voters are comfortable with the new technology, public and voter education programs must be developed and implemented. These programs should inform the public about the advantages of blockchain-based voting, how to use the system, and where to seek help if needed. Ensuring that the electorate is well informed and confident in the security and transparency of the system is crucial for its success. Blockchain-based voting systems should undergo rigorous testing and certification processes to ensure their accuracy, security, and resilience. Independent bodies, including cybersecurity experts and election authorities, should assess the systems for vulnerabilities and potential risks. The governance of the blockchain network used for voting is a critical consideration. Decisions related to upgrades, maintenance, and network operation should be made in a way that ensures the integrity and continuity of the voting process. A well-defined governance structure should include participation from relevant stakeholders and follow established governance models, such as on-chain governance or delegated consensus mechanisms. In conclusion, Blockchain technology holds great promise in revolutionizing digital voting by enhancing security, transparency, and accessibility in a detailed manner. By leveraging the decentralized and immutable nature of blockchain, digital voting can become a more secure and trustworthy process, rebuilding trust in electoral systems worldwide. The application of blockchain in digital voting offers a solution to long-standing issues in the electoral process, from securing votes and ensuring transparency to increasing accessibility. Addressing the challenges related to identity verification, scalability, user-friendliness, privacy, and legal considerations is vital to realizing the full potential of blockchain in the realm of digital voting. As technology and regulations evolve, blockchain-based voting systems may become an integral part of modern democracies, fostering more transparent, inclusive, and secure elections. While there are challenges and complexities to overcome, the promise of a more secure, transparent, and inclusive electoral process is a compelling reason to continue exploring the application of blockchain in modern democracy.